Alright, here we're going to look at composites. So if you look at problem 31, we have f of x is equal to x squared, g of x is equal to 2x plus 3, and they say find the composite. Alright, so what we're going to do is take this one and plug it in here. So when we do that, we end up with, I'm going to put in parentheses of what we're replacing. Sorry, that's the other way. Alright, so here what we're going to do is take this and plug it in there. So it's going to be squared. So we end up with 2x plus 3 squared. Now if you remember your rule, or your little, you could go through this a little bit quicker, but I'm going to write out as 2x plus 3 times 2x plus 3. Okay, I'm going to multiply, distribute everything through. So I'm going to get 4x squared plus 6x plus 6x, okay, plus 9. And then combine like terms, so I end up with 4x squared plus 12x plus 9. Now for those that remember, if you square the first term, you get 4x squared. Multiply them together, you get 6x. Double it, you get 12x. Square this one, you get 9. So you can come up with the either way, but either way you should come up with this answer, 4x squared plus 12x plus 9 for that. Now let's look at 32. We're going the other way. Same functions, but we're told composite. So we want to take the f and plug it into the g. So f of x is x squared, g of x is 2x plus 3. We're going to take this and plug it in here. So it's going to be 2. So all that stays the same. We're just replacing the x with x squared. Okay, so this one we're just going to, we don't need parentheses here now because it's just going to be 2x squared plus 3. So when we find composites, we're taking one and plugging it into the other. Alright, now for 33, we're given a table of values, -2, -1, 0, 1, 2, 3, and we have f of x, -7, 0, 1, 2, 9, hang on, I'm off a little bit here, -1, 0, 1, and then, hang on, let me make sure my numbers match up. I'm trying to go through it. Alright, -2, -7, -1, 0, 0, 1, okay. 1 goes with 2, 2 goes with 9, and 3 goes with 28. Okay, and they want us to do the inverse. Now, in the inverse, we switch the input and the output. So what we would do here is our x and y's would switch. So I'm going to write this and tell everybody this is an inverse. So what's going to happen is that's going to be -7 and that's going to be -2. That's 0, that's -1. That's 1, that's 0. That's 2, that's 1. That's 9, that's 2, that's 28, and that's 3. So we have found the inverse because we switched the input and the output. Now, algebraically, we would switch the x and the y as that goes. Now, as far as the D part, does it seem to be 1-to-1? If you just look and if you notice here, we're not getting double ups in our range. Every y only has one x. So yes, all y values, okay, have a unique x values.